So we're just going to I'll continue on from where we left off last week, as per usual. So last week we were sort of mainly looking at the moving into, I guess, more complicated things in programming and processing. We looked at object-oriented programming and talked about what that all means, how it's sort of a different way of thinking about programming compared to the usual sort of here's an action, here's an action, here's an action. We instead classify things as objects which have a set of data and methods which operate on it. And then we started on processing themes from memory, and we looked at some interaction stuff. So we talked about mouse and keyboard interaction, and then we decided to leave it there. Did anyone have a play with this since the last lecture? Some yeses, some nos. That's all right. You know, again, it's not. I'm not going to be checking this, but you know, the more you guys get into it now, the easier it's going to be to remember this stuff. So we're going to move on to some of the more complicated things, I guess, in processing. Some of these more complicated themes today, and we'll see how we go with those. I suspect this will potentially be the rest of the class, but maybe not. So we're going to start. The first thing we're going to talk about is a bit of a, I guess, an aside to processing themes, and it's talking about external libraries, which are basically things which extend processing's core functionality. And some of the things we're going to look at use external libraries, so it's probably worth talking about. So processing has a bunch of core functionality that we've looked at. However, there are also a wide range of libraries which have been contributed, which allow us to do stuff which wasn't included in processing by default. The reasons that they would have been not included in processing is more bureaucratic than any functional reasons. So it might be things like maybe processing's open source and stuff, and maybe these libraries use some closed source software. So the difference open source being that you're allowed to edit it, you're allowed to see the source code, how it was written, you're allowed to edit it. And sometimes people like to use closed source libraries. So perhaps you want to play a video and they want to include a video player which is closed source. The way software licenses work is sometimes they can be quite viral, for lack of a better word, in that if I include this piece of software with this license in my code, the fact that it uses that license then means that I have to change the license of my code. It's no longer like, I'm going to pick and choose this and that and put it in my software and everything will be happy. Sometimes it's like, well, in order for me to include that legally, I have to change the license of my code so that it's no longer the license that I want to use. And there are a range of reasons like that, that they may have. It also may have been things just to keep the file size smaller, so it's not including a bunch of stuff that we're never likely to use, and so on and so forth. But anyway, processing has had, obviously it is a community-based sort of piece of software, and as such, there's a wide range of community-based plugins which allow us to do a range of other things. So actually, if we go back to the processing website, so on the processing website, you can see here that we've got libraries, and if we click on this, we had a look at some of these. We talked about the libraries which are they're bundled with processing in that they're included, but you still have to specifically include them. But then there's a whole bunch of contributed libraries that other people have written. So we talked about a few of these. You know, if you wanted to do something specifically with typography, you could click here, and there's various typography things that you can use. So as far as how to use these things, one thing we're going to look at today is user interface stuff. So we can see here there's a GUI, and if we click on that, you'll see that there's a bunch of different GUI libraries that you can use. And we can click on the names of any of these to have a look at their GitHub pages. So GitHub is an online source code repository. Some will probably be more useful than others. Here we go, here's one which is slightly nicer in that it actually has some illustrations which show what the libraries are like. The rest of them are a bit, this one doesn't actually show anything, but we're going to be looking at one in particular. This one doesn't actually even point to anything anymore. so probably don't use that one. So we're going to look at Control P5 today, which is sort of one of the, I guess, potentially more complete ones. It can do lots of nice GUI stuff and sort of save us the drama of having to do it ourselves. Whose phone is that? Is this Greg's, perhaps? Greg, is that your phone? Was that you calling it? All right, we're just having a distracted morning, aren't we? Cool. Okay, so we're going to look at Control P5. So there's a few ways of... there's a few ways of importing these contributed libraries into processing, but the easiest way is actually built into processing itself. So if we open processing and go to the Sketch menu, so I can't remember what it's called in Windows, but it's probably also called Sketch or something. If we go down to Import Library, you'll see there's a few different libraries in there, or there's a few different options in there. So these top 5 here correspond to these, well, there's more than 5 there, but they correspond to these ones here. So you can see there's DXF export, there's the network, there's PDF export, there's serial, and there's SVG export. So basically those 5 there. Video and sound are sort of now built into processing natively, so they're not really libraries as much as they used to be. So this page is probably a little bit out of date. I'm not sure what the status of hardware I/O is, but we won't be looking at that anyway. So we've got these ones here we can import, and clicking on them you'll see just adds a line of code to the top of our processing file. So if we did say import PDF, you see it puts in this import processing.pdf.star. So this looks kind of similar to what we've dealt with when we're talking about classes before. So it would have like class car, and then we'd say like car, my car dot something to call the something function on my car. And here we have processing.pdf.star. So this is kind of a similar thing. You could imagine that you have a class called processing, and inside that it has a class called PDF, and inside that it might have a bunch of different classes, print, PDF, whatever, and some other classes on top of that. So importing processing.pdf.star is basically including everything in processing PDF, and the star is just a wildcard, which means everything. So effectively, every class which is inside processing PDF would be included, and then we could do some stuff with that. So we can have a look here. What in that case this library does is a little bit different than what we might expect. So let's import this one. We'll just do this example so you guys can have a little look. Oops. So we're importing our PDF classes. I don't know what's more wrong with the clipboard on my machine now, but it never seems to actually copy stuff anymore, which is a lot of fun. Void draw. Okay, so let's comment that out first. So there's a few things to unpack here. So if we just ignore the PDF stuff for the moment, we have our setup function, which calls size 400 by 400, so it creates a new window that size. We draw a line from 0, 0 to width divided by 2, height divided by 2. We print finished, and then we exit, which is a function we haven't looked at before, but as you might expect, it exits the program. So you can see that window popped up and then disappeared almost immediately. If we comment that out so it doesn't kill the window immediately, we can see effectively we've drawn a line on the window. So that's what's happening. It's calling draw once and then it's exiting the program. So what processing PDF adds is this other option that we're going to talk about the other options for size probably on Thursday, but size is an overloaded method as well, like a lot of processing methods are. So we're familiar with size with 2 integer arguments that tells us what the size of the window is. There's also size with a 3rd argument, and there are various options we can do there, like P2D, P3D, and that changes what's known as the renderer in processing. So the renderer is basically what's responsible for drawing stuff to the screen. Whenever we want to do 3D graphics, we'll do something like tell it P3D, which tells it to use a 3D renderer. In this case, oops. In this case, it probably, if it works, yeah. So it won't make a difference at all because we're still only doing 2D stuff, but it now gives us the option of doing 3D stuff. Additionally, there is another 2D renderer. It seems to be throwing some stuff out. So processing has 2 2D renderers, P2D, and I can't remember what the other one is off the top of my head. But the other one is the native one and uses processes rendering stuff. P2D uses a graphics library called OpenGL, as does P3D. You're very unlikely to notice a huge amount of difference between the regular one and P2D. The only thing, if we can actually see, is that line is potentially slightly thicker there than it is here. No, not even really, but one thing we can notice is that when I run on P2D, my Mac throws a little tizzy and we get a bunch of error messages printed out. So you can see there's a ton of error messages, so something on my Mac is not particularly liking using P2D. But anyway, so the size, width, height, and we have an optional argument of which renderer to use. Processing.pdf includes this new renderer called PDF, and it also takes another argument, which is the name of the PDF file to write to. So it doesn't make sense to draw multiple times to a PDF, so we can just draw that once. And hopefully now, if we open our sketch folder, in here we'll have file.pdf, which is a PDF, and when I open that, we can see it's what was drawn in the window before. So if you guys create a program which does some nice graphics and stuff, you can actually use the PDF renderer type, which is included in processing.pdf, to render straight to PDF. And the good thing about that is that PDF is what's, no, I don't think we talked about that in this class. There's 2 different ways of representing graphics. There is what's known as raster, which is basically you represent a graphic by a series of pixels. So you say, here's a pixel, here's a pixel, here's a pixel. Just like if you were doing using a paint program and you zoomed in really close. I don't know if Pinter does it, but particularly on things like Microsoft Paint and stuff, if you zoom in close enough, you can sort of start working with individual pixels. So there we can see the individual pixels which are in this. So this is raster, and effectively all we do for this image is for each pixel in a grid, we just say what color should be in that pixel. So as you can imagine, that's quite, it takes up quite a lot of memory, because if this is a 200, or let's say 256 by 256 image, and we want to store 255 bits, so a grayscale value, we can represent that in 8 bits, which means that a 256 by 256 grayscale image is 524 kilobytes, so half a meg effectively just for a small image. That's obviously uncompressed, so that's like a bitmap format, but even with compression, it's often larger than it absolutely needs to be. What PDF uses, it uses a different type of image format called a scalar image format, where instead of, or a vector image format, sorry, where instead of representing each pixel or an image as a series of pixels, we represent it as a series of shapes and mathematical equations and stuff that we use to draw an image. So instead of this sort of S shape I drew here, what we'd try and do is fit a curve or a series of curves to that. So we might say, well, there's a straight line which goes from here to here, there's a straight line which goes from here to here, there's a straight line which goes from here to here, and represent each of those lines mathematically in the formula, and then we can just say, rather than having to represent maybe 100 pixels here, we can just say there is a line which goes from xy here to xy here, which really is sort of 4 numbers we need to represent rather than 100.
It's helpful for later editing as well.
Yeah, so, and it's, yeah, exactly. So it's good for editing as well. So if I take this image and I zoom in, eventually we're going to get this really blown out, pixelated thing. With a vector image, because it's done mathematically, we can zoom in or zoom out infinitely, and all we do is we just recalculate where all those lines should be when we render it. And that is what PDF is usually represented. So PDF is a container file format. It can contain a bunch of different things, but it can contain vector graphics. And so this image here, which is effectively a grey box with a single line in it, that was a 400 by 400 image. So if we say 400 by 400 by 8, we're looking at about 1.4 megabyte if we just want to represent that as a bitmap. In the PDF that we've exported, it's 833 bytes. So it's a really, really small image divided by 833. So it's about 1,700 times smaller than if we save that as a bitmap. So PDF is kind of a nice file format if you're doing stuff which can be represented mathematically. And again, I don't know how well this renderer will handle it, but that's all right. So you can see as I'm zooming in, that line is never getting more and more pixelated like it did in the other one. It's just getting thicker. So there's none of this pixelation around the outside like we see here. It's still a nice sharp edge because it's being represented as a mathematical formula. Okay, so that was a bit of a digression, but it gives you an idea if you want to. I know in Christoph's design course, he often had the students design a PDF using processing, but unfortunately we always sort of had this conflict of who was going to reach that point in the course first, and unfortunately Christoph often bet me, so the students were always a bit frustrated that they'd be doing PDF exporting before we'd actually talked about it in the programming part of the course. So I don't think Anthony's planning on doing that this time, so you don't have to worry about it, but you know that it's there in case you produce some really beautiful artwork and want to export it as a PDF, so you can blow it up to A0 size and still have it nice and sharp and everything. It's there. Okay, anyway, after that massive digression, importing libraries. So we've looked at some of the existing ones, but what we could do if we want one of the contributed libraries, the easiest way is just go import library, add library. And you'll see it will pop up with a ton of libraries in here. Hopefully all the ones that we see on this page and possibly some more. What we can do is we can click on all and we can go down and change it from all libraries to just certain libraries. So if we're just looking at GUI, for example, we can click on that and you can see we've got all those libraries there that we did have in here. So Meter, Interfacia, Guido, Control P5 and all that sort of stuff. So if we want to install one of these libraries, we just click on it and we click on install and you'll see it's downloading it and it's going to do the installation and everything for us, and then we get a little tick by it to say yep, it's done, it's installed. Likewise, there are other things you can install. So if you want to, there are different modes. So if you want to develop for Android or whatever the stuff, there's tools. So we've looked at 1 or 2 tools, mainly just like the color selector, but there are some other tools in there that might be useful, and there's some more examples in there as well, but we're just going to look at libraries for the moment. So once I have added a library from the import library thing, we'll notice that now down below the original libraries we have a list of contributed libraries, and down there we have our Control P5. And if I tap on that, you'll see it puts import control p5.star, so it's bringing in everything from the control p5 library, and then we're ready to start doing control p5 graphics. Okay, so that little digression was simply to bring us into the user interfaces, because we're going to be using control p5 to do some user interfaces. Control p5 is I would say not the ideal graphics library, but of the ones that I've seen for processing, it's probably one of the better ones. Of course, we are free to build our own one if we wanted, and we looked at some examples of how we could do that by drawing boxes, and then we can detect the mouse position and detect if it's been clicked inside a box. But Control P5 provides a lot of that functionality already, so we don't really need to worry too much about it. So you can add graphical controls like buttons and sliders and drop-down boxes and all sorts of stuff. So here's one of the examples. I should have made a list of which one it is, but here's one of the examples which shows a range of different sort of user interface elements that Control P5 provides. There's a couple of websites we can go to have a look at Control P5, which you can just get from the libraries method will take us there. But you can see that you know, there's some information. He's got some images, including that one which I stole from the web page, and some information about various bits and pieces that you might want to do. There's some information about installation, which you don't need to worry about because I've already handled that. A list of its features, a list of examples, which we can have a look through, and the Java doc reference, which is possibly more useful. So Java doc is a way of automatically generating documentation for code. Everything which uses Java doc has a sort of similar look and feel about it. It's very tech oriented, so if you guys haven't done a lot of programming and you haven't seen Java doc before, it may look a little bit overwhelming. And unfortunately it probably is more than it needs to be. But the idea is you have a list of all the classes, so we've talked about classes now, but these are all the classes which are included in Control P5. So we can see there's an accordion, background, bang, bitfont, blah, 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 blah. And so if you want to get started, what you do is you'd have a look down the left-hand side for something which sounded like something you wanted to do. So say we want to put in a button, we might click on this button example, and then it will bring up the documentation for our class button. So button is a class just like our car classes, and we wrote everything before. And then if we scroll down, we can see a list of fields. So in this case, fields are our variables. So it has two, auto width and auto height, which come in class button. But then there's also a whole bunch of other classes that fields that it inherits from other classes that it inherits from. Probably should have talked about this earlier, but I haven't. So let's talk about that now, actually. Yeah, I'll do it in code. So this is, if we just cast our mind back to the object-oriented programming, there was something that I should have talked about at the time, but probably didn't. But that's okay, let's talk about it now. Okay, void setup student. Okay, so can I make that small? So just, sorry, I should have spoken about this last week. So if we look at this example here of object-oriented programming, we have a class here for student and a class here for teacher. So two classes, we're going to create some objects of them. So one called S, an object called S, which is a student, and an object called T, which is a teacher. The teacher class has a function called teach, which just prints I am teaching, and the student class has a function called learn, which just prints I am learning. So we create a new student, a new teacher. We call the teacher object, or the T object of type teacher, tell it to teach, and the S object of type student and tell it to learn. And if we run this, hopefully we will get t.teach, we'll call teacher teach, which will write I am teaching, and student.learn we'll call, or s.learn we'll call student.learn, which says I am learning, and so we get I am teaching, I am learning printed out. Make sense? Yep. Very basic example, hopefully everyone's happy with that. Okay, so students and teachers are separate classes which can do their own separate things, but realistically students and teachers have some similarities as well. So they're both people, so they can both eat and they can both sleep. And so what we could do is if we want a teacher and a student to both be able to eat and sleep, teacher eating, teacher sleeping. What we could do is we could give both student eating, student sleeping. We could give both the student class and the teacher class an eat and a sleep method, and then we could say t.sleep, s.sleep, t.eat, s.eat. So before they come to teach and learn, the teacher's going to sleep and the student's going to sleep, and then the teacher's going to eat and the student's going to eat, and then the teacher's going to learn and the student's going to learn. And so if we run this now, so the teacher's sleeping, the student's sleeping, and then the teacher's eating, the student's eating, and then the teacher's teaching and the student's learning. So we could do this. We could basically say, okay, well, both students and teachers need to eat and sleep, so let's give them both an eat method and both a sleep method. However, that's not really kind of a good way of representing that, because it's sort of implying that the way a student eats and sleeps is different from the way a teacher eats and sleeps. There's not a consistency there, but really eating and sleeping is something which is intrinsic to humans. And teachers and students are both humans, so everything they should do as humans should be the same, more or less. And it's only the things that they do differently which says that this is a student and this is a teacher. So students are people and teachers are people, and they both do people things. And the thing which differentiates a student from a teacher is that a student can learn and a teacher can teach. So what is actually a better way of doing this is, in addition to having a teacher and a student which have their own unique things, so a student learns and a teacher teaches, we could also have a class person, and a person does everything which is intrinsic to people. So in this case, a person will eat and sleep. So a person eats, a person sleeps, a student is a person, and a teacher is a person. Okay, so we've got a person here who can eat and sleep. We've got a student who can learn. We've got a teacher who can teach. But you'll notice here, we haven't at any point in time said that a teacher should be a person or a student should be a person. So we get errors here that the function sleep does not exist for the teacher, the function sleep does not exist for a student, and so on and so forth. So what we need to do is specify that a student is of type person. Now I do apologize that I haven't tested this yet. Yeah, there we go. So what we need to do in Java is we need to, in processing, sorry, and in Java, is we say that class student extends person. So we're saying a student can do everything a person can do, but they also extend that behavior. They're adding something else to it. So by using this extends person, we're saying everything a person can do, a student can do, but they also have these extension methods. So in this case, a student can learn. And likewise, we can do the same thing with a teacher, extends person. And so now a teacher can do everything a person can do, but a teacher can also teach. So if I run this now, we'll get person sleeping, person eating, person eating, person eating, I am teaching, I am learning. So when we call t.sleep, that's effectively saying to the teacher, do you have a sleep method? It's saying, no, I don't, but I also extend person, so we need to go back and check person, and it says, does person have a sleep method? Oh yes, it does, person has a sleep method, person is sleeping. So what if we wanted to make these a little bit more, I guess, specific? So we still want to know if it's the teacher eating or the teacher sleeping. What we could do is we could say, okay, well, every person has to have a name, and let's print out the person's name when we're saying eating and sleeping, so we know who's doing what. So now the name, when we call person.eat, we're going to pass out the person's name, eating. When we call sleep, we're going to pass out the person's name and sleeping. And because a student is a person, what we can do is we can access that person's name and we can give it a value. So in the constructor now, I've said when we create a new student, set that person's name, which is also the student's name, to student. And when we're a teacher, or when we, in the teacher constructors, when we create a new teacher, let's set that teacher's name, to teacher. And so then if we're creating a new student, in the constructor here, we're going to set the name student. When we're creating a new teacher, in the constructor, we're going to set the name to teacher. And so now if we run this, we'll see teacher sleeping, student sleeping, teacher eating, students eating, I am teaching, I am learning. So both the teacher and the student now are able to eat and sleep because they're people, and everything that a person, or the way a person eats, and what that means for this person class will be the same for both a student and a teacher, because ultimately they are both people. And so what we've actually just designed here with this class teacher and class student and this class person and student extends person, teacher extends person, this concept in object-oriented programming is known as inheritance. And it's often written kind of like this. We have a person, and that person can eat, and that person can sleep. And then we have a student, and that person, that student can learn. And then we have a teacher, and that teacher can teach. Bless you. And these arrows basically show, with a little arrow at the top, that both student and teacher inherit off person. So everything a person can do, a student can do, everything a person can do, or everything a person can do, a teacher can do, plus a student can also learn, and a teacher can also teach. So this is a very stripped down and probably wrong version of a thing called UML, or Universal Markup Language, I think it's called, but it's a way of basically drawing out our object-oriented programming so that we can look at this quickly and understand what is going on here. So I can look at this and say, we've got three classes: a person who can eat and sleep, a student who is also a person, so they can eat and sleep, but they can also learn, and a teacher who is also a person, so a teacher can eat, sleep, and they also can teach. So this is a very succinct way of writing up, designing classes and stuff like that, so we can very quickly look at that and understand what's going on. So inheritance is a very powerful addition to object-oriented programming. Not only can we sort of say, well, these are a bunch of properties and functions that are specific to a type of thing, so a student or a teacher, but we can then use inheritance to extend that and say, well, actually, teachers and students are both people, so everything a person can do, they can both do, but they also then add their own things that they can do. And it can be functions like this, it could be data, so perhaps a student would have a student ID, and a teacher might have a salary or something like that. And so now a teacher has a salary, and a student has a student ID, and a person has a name, And so a student will have a student ID and a name, a teacher will have a salary and a name, and so on and so forth. So does that make sense to everyone, hopefully? So I'll save that and upload it. Inherit. Okay, but the reason I wanted to talk about that is if we go back to our if we go back to our Java docs for our control P5, we can see here we have class button. So so somewhere in control P5 we will have class button, which will look like that, and it has some variables or some fields, they call it here. They have an int for auto height and an int for auto width. So we can see those two fields there. Don't worry what static means at the moment, but int auto height and int auto width. But then we can see it says fields inherited from class control P5 controller. So there is also a class in here called controller. And we know that because it inherits it, button must extend controller, like that. And in controller, it has some function called auto spacing, which is a float, or an array of floats. And if we go back, we can see then that fields inherited from interface control P5 constants. So what's probably happening here is there's another class called control P5 constants, and controller probably extends, that control P5 constants. So we have this chain of inheritance where if we're looking to use a button, we know that a button extends controller, so everything controller can do and every piece of data that it has, button also has, and controller extends control P5 constants. So everything that control P5 constants has and can do, controller can do, and thus button can do. So the button itself only has two fields, so two things we can change. But the button also gets the controller's auto spacing, and it also gets all these things that control P5 constants has. In this case, there's probably not a huge amount of stuff that is particularly useful for you, but I just wanted to explain. So when you look at the Java docs for these things, you can say, okay, so my button, I want to edit something about it. Okay, so it has an auto width and an auto height and auto spacing, and it also has all of these things as well that one of these might be the sort of thing that I'm trying to change. So then if we scroll down, these are the constructors for button. So button has two constructors, one which takes no arguments and one which takes control P5, the control P5, and some other stuff as well. And then it has a bunch of methods. So all of these are methods that we can call on our button when we create it. We can check to see if it's on, so whether it can be clicked on. We can check to see if it's been pressed. Is it a switch or not? There's some methods, mouse pressed, mouse released. We can set whether it's on, so on and so forth. And then it inherits a bunch of methods from the controller class. So down here we'll see some things which are possibly more useful, like set height. Somewhere in here will be set width. So if we want to set the width and the height of the button, we can do that. But that actually comes through from the controller. Yeah, and so all these things, if I wanted to know how to set the width or set the height of a button, I can look into here. Or say I'm creating a button, I want to know how to set its width or height. I can just type in width. Auto width, probably not right. Get width, set width. There's one in there. It's inherited from control P5 controller, so I can probably, on here, if I was doing something with my button, say b.setWidth, and give it a width that I want to set it as. So that's a lot to take on at the moment, I understand, very probably overwhelming, but that's okay because we're going to work through some examples nice and slowly soon. I just wanted to show you guys what the Java docs look like, because unfortunately this is the best reference that we have for Control P5, and it takes a little bit of getting used to understand what all these things are doing. But that's okay, because we're going to have a look at some examples. So one thing I haven't mentioned yet is when we added our contributed libraries there, and in fact, I haven't talked about this at all yet. So we've imported our libraries, we have our contributed libraries. There's something else in processing that we haven't talked about yet. So in processing, if we go to the file menu and we look down, we'll see a menu or an option in the menu called examples. And if I click on that, it's going to pop open. It's going to pop open this window that has a ton of different examples that we can do, we can use that are built into processing, and they're sort of categorized in a few different ways. Sorry, I know this is quite hard to read, but we have basics, which will give us a bunch of basic examples. So say I wanted to do something with data. There is I can open the data folder in basics, and there's one called variables, and if I open this up, we'll see here is some examples of variables. So we have some stuff that we hopefully are familiar with now. We set the size, we set the background, we set the stroke color. We haven't talked about stroke weight, but that's just the thickness of the lines. The stroke cap, if we went back to this PDF, stroke cap defines how lines are ended. So in this case, we can see they're circular. Here they've said stroke cap is square, which will make the end square. We set up some integer variables, A, B, and C, and then we draw some lines and so on and so forth. And if we run this, we can see it's drawn 3 sets of lines for us. So there are a ton of different examples. This is actually, in addition to the open processing stuff, this is a really good resource if you guys are wanting to do something. Have a look in the processing examples and see if there's anything in there which might be handy. A lot of the stuff is stuff that we haven't really looked at yet. So there's a lot of stuff in there for like camera, which we'll talk about when we get to 3D graphics, and images and lights and shapes and all that sort of stuff that we'll talk about when we get to the graphics part of the course. But there are some stuff, so for example, if you want to look at some examples on object-oriented programming, we can go into basics objects, and there's an objects one here which shows us how to set up a class, in this case mrect, and mrect has some variables and a constructor and some functions. So when we run this, it's doing some stuff. I don't know, these boxes seem to be following the mouse around. So there is a ton of examples. We have basics, which is basic examples. We have topics, where things are more split into learning topics. So for example, if I wanted to learn a lot about GUI, there are some GUI-based stuff in here. This is processing sort of, not really proper GUI, but doing stuff with like drawing circles and checking to see if the mouse is over things by its position, stuff like that. So this is not GUI as you would normally think, but this is what we talked about how you can draw a box and detect if the mouse is over the box. If you wanted to do some stuff around interaction, curves, all that sort of stuff. So basics and topics sort of cover the built-in processing stuff. Basics is more basic. Topics sort of each one follows. If you work through them, you'll get an overall understanding of that specific topic. And there are some more in-depth demos as well. But then the bottom two are the ones that I wanted to look at the moment. So in libraries, you'll notice we have DXF export, network, PDF export, and serial, which are four of these 5 examples we see here. It doesn't have SVG export for some reason, but the rest of them are in there. So before we found an example of creating a PDF just on the web page, but we could also just go into processing, file, examples, and then look in libraries, PDF export, and you'll see there's a range of other examples in there. So we can open up one, and if we run that, you can see it's printing a very pretty 3D pattern of sort of curves, and I would assume that maybe somewhere in here, so there's a do save method that if we push S will turn on do save. So if I run this example and when it's in a place I push S, it will complain that it can't save it to that directory. So I would have to save it somewhere else. Run that again. Push S. And now hopefully if I go into Sketch, show Sketch folder, we'll have a PDF complexout.pdf, and if I open that, there's the PDF that's been created for me. So there's a bunch of examples for the contributed library, for the libraries which come by default. However, after we've installed Control P5, we'll see that there is this contributed libraries folder, and if we open that up, you'll see there's now an entry for Control P5, and inside that there are a bunch of subfolders, and each of those have a bunch of different examples in them. So Control P5's online reference manual is all Java doc and is kind of confusing and difficult to use. What is potentially more useful for you guys if you want to do some stuff with Control P5 is actually go into the examples and look at the examples, because at least then they're real world examples. You can open them up and you can like test them out and try and understand how the things work from that. So that button example that button page we looked at before didn't have a huge amount of information on it. So instead we could open Control P5 button, and you'll see in here it's got a bunch of code, and they have commented them as well. So create a new button with the name button A, add another 2 buttons, function color A will receive changes from the blah, 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 blah. So there's a bunch of information in there, and I can run it, which is nice, and actually see what we have here. So we have 3 buttons, and I can click on them and it changes the colors of the various screens or the backgrounds, and there's a couple of buttons down here which do things. So this is probably potentially a slightly easier way of figuring out how to use these things, because you can go in, particularly if there's something that you're not familiar with. So what is an accordion? We can click on that and we can run it, and we can see the accordion here is having a list of menus that we can fold up or fold out to show various things. So there's a bunch of these this is an accordion with 3 groups in it, and each group has a separate set of controls that we can modify and we can collapse if we want. And there are a whole bunch of other examples. I would highly recommend going through the various examples, even if you're not necessarily going to be using Control P5 for much. It's probably worth just going through each of these things and just having running each demo and just seeing what each demo does, because it might illustrate, or if you want to do something using graphical interfaces, at least this way you can sort of see what the various controls do. So you can sort of say, oh, I saw that control, it was called a chart, and then you can go in and look to see how a chart works. So we'll just try and get through maybe this slide before we have a short break, and look at how we actually can start building a Control P5 example. Close down some of those. So let's start a new processing file or processing sketch, and let's import library contributed Control P5. So we're all set up now and we can start doing our Control P5 stuff. Let's throw in a setup method, and one thing I've included in the slide, make sure you have the draw method or nothing will respond to events. So we have to make sure we have a draw method. There doesn't have to be anything in it, but it has to exist, otherwise Control P5 won't work properly. Okay, so unfortunately there's a little bit of housekeeping we have to do before we use Control P5. There is a class called Control P5 in Control P5, which is sort of our thing that we use to create everything. So we just have to create a new class called Control P5. In a setup method, we have to instantiate it like this. So effectively we have a class called control P5. We want to create a new object of that called CP5. And so we're basically saying outside so that we have it for the entire scope of the program, control P5. And then in our setup method, we're going to actually create or set aside that memory using the new control P5 keyword. So the reason we have to do that in the setup method rather than doing it out here is that control P5 has to be created with this inside the brackets. So we haven't really talked about what this means, but effectively this is, if you think of the code you're writing as a class, so where are we? If we go new. So I'm creating my project, and we've talked before about scope. So if I have int x equals 0 out here, that means I can see the value of x in setup, but I can also see the value of x in draw. And I said the easiest way to think about scope is look at the closest brackets, squiggly brackets, which encompass it. So I said you can think about your project as looking kind of like that. So we have a squiggly bracket before and a squiggly bracket afterwards, and that int x exists from that squiggly bracket to that squiggly bracket. You guys all remember me saying that? Well, what's actually slightly truer is we can think about our entire project as a class like that. And so now instead of just being just some squiggly brackets, all our code is inside a class. So this is actually a more accurate way of sort of thinking about what's happening behind the scenes. So when we talk about this, effectively what we're talking about is the object that contains our class. So if I say, let me think about a way to do this. My class setup, my class draw. So I'm sort of confusing what we're doing here. So we have a class called my class with my class setup, my class draw. Imagine that this is actually called setup and draw. I've just changed the names to hopefully be slightly less confusing. And then what processing does is it has its own setup method that creates a new copy of the class that you've written and then calls setup, and then we'll call my class setup, and then it will have its own draw method which will call your my class draw method. So you can imagine that somewhere in processing this exists and you're writing the code for my class. So when we call when we write our setup method, processing is calling your class.setup, and in the draw method it's calling your class.draw. What this function does is basically allows your class to call itself. So if I say println this.x, it's the same as basically saying print my x. So in my class setup, we'll see in setup we call my class setup, and in my class setup we're printing this.x, and it's basically printing out the value of x that belongs to that specific object. So that's probably a bit more background than you guys really need to know or understand. But effectively what we see here is we say we're creating a new control P5, and when we call the constructor for it, we pass in this, which effectively we're passing in our own class. And what that allows control P5 to do is if we create a button, so we say cp5.add button, my button, what control P5 will do, it's a name, not a thing. So we're creating a new button called my button. By passing in this, what that will allow us to do is have a function called my button, and control P5 has a reference to this class, so it can call this method. because it's basically like saying, in Control P5, it would basically be like saying my class.myButton, because it has a reference to my class. That's probably too advanced for where we're at the moment. I guess it's just a little bit of background about what the this function does. But effectively, the this function allows Control P5 to call functions in the code that we're writing. If we didn't have this, Control P5 wouldn't be able to call my button because it doesn't know what class it's trying to call it on. You guys, I don't expect you guys to be able to understand that. You know, that may have just gone completely over your head, and that's absolutely fine. But what is important is that you guys know that you need to, when you're calling Control P5, the constructor, you need to pass in this, which gives Control P5 a reference to the code you're writing so that it can then call functions in your code. So we have the things that we're doing to set up Control P5. We're importing it. That is added for us automatically when we say import library Control P5. We're creating a new object of type Control P5, and in our setup, we are calling the constructor on that, so new Control P5 with this. So we've had to write 3 lines of code, really 2 lines of code, because this one gets written for us, but that's what needs to be done to set up Control P5. Once we're done with that, Control P5 is set up, and now we're free to start adding stuff. So if I run this now, you'll see nothing happens, although we do get some extra text written in our thing, Control P5, info comments, and that gets written when we call our constructor, but we're now effectively free to start adding elements. So we've added 2 lines of code, or 3 lines of code, depending on how you look at it, and now we can start adding things. So let's fill out a few other bits and pieces. Let's increase the size of our window so it's a bit bigger. And let's add our very first Control P5 element. So we're going to add a button, and we're going to call it my button. And now if we run this, we will see that we have a button on our screen, and when I mouse over it, it will change colors, and when I click on it, it will change colors. So we've created our first button, and it has the text my button that it got from the name that I've given it. So maybe what we want to do, how best it is. Yeah, so when we call add button or anything on our Control P5 method, it actually returns a reference to the button that we're getting. So we could say button my button equals Control P5 add button my button, and now this my button here is a new class or new object which has been created by Control P5 add button. So just as we might say button my button equals new button, and in fact that will work. By saying button my button equals control5.add button, Control P5 will create the button using new.button, but it also allows us to set out a bunch of additional things. So it will attach it to the scene, it will set up all the handlers and everything like that. So these 2 functions are kind of similar, but calling Control P5.add button or CP5.add button will set up a whole bunch of additional stuff in addition to calling new.button. If I wanted to call new.button, I'd have to say add it to Control P5 anyway, and then I would have to we'd have to set up its label, add a bunch of other stuff. So calling Control P5.add button is effectively doing the same thing, but it's doing it in a lot less steps. So we're going to delete that because this is much easier for us to use. So button my button equals Control P5.add button. We'll create a new button on the screen with the label my button, and then it will assign its value, well, it'll assign the value of that or the class of that or the object of that to the my button variable. And that means then I can go on to say my button.setWidth, so I can change the width to something different. So now it's a lot wider than it used to be. I could say my button.setHeight 100 and change the height of that. So now it's a much bigger button again. And there's a bunch of other things I can change. So there's a bunch of functions we can do. We can do buttons, we can do color pickers, we can do accordions, we can do knobs, we can do graphs, blah, 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 blah. All those examples that we saw in examples, contributed libraries, Control P5 controllers, all of these are things that we can now add using these pieces of code here. So I mentioned before, make sure you include the draw method or it will not respond to events. So just to show you what I mean, if we run this, we've created our button, we've given it the name my button, so that becomes a label. We have set its width and its height. You'll notice when I mouse over it, it changes color, and when I click on it, it changes color as well. If I remove my draw method and try run that again, you'll notice that when I mouse over it, nothing happens. When I click over it, nothing happens. So when I say make sure you include the draw method, if you don't, it will draw the buttons, but they won't work. Okay, let's have a 10-minute break there, and then when we everyone good, back into it. Enthusiasm, love it. Okay, so I've looked at adding a button. Let's just have a look at one other example so we can see what's going on here. So let's add a color picker. My color picker. And we use the same functionality, cp5.add color picker, and we give it a name. And if we run this now, you'll see that we have this color picker up in the top left corner because we haven't set its position, and we have a button as well underneath it. So likewise, I can use my color picker dot set x, is it? No. What is the set position? Right. Set position 200 by 200 will allow me to move the color picker down to 200 by 200. Okay, so we've got, and likewise the rest of the elements, user interface elements can be created in the same way. So by calling Control P5 or CP5 dot add whatever thing we want. The one thing we have to be careful of is just that we give every element its own separate, its own individual unique name. We'll look at that in a moment. But yeah, otherwise we call add whatever, and then we can get a reference to that, and then we can use that reference to change the width and the height and the position and the labels and etc, etc, etc. So that allows us to create our things. What about actually doing something with them, changing the behavior of our application when people interact with these things? Let's come back to that. So events are received by the control event function. So no, actually, let's start with the second one. So part of the reason why we have to give everything its own unique name is because Control P5 will create or call a function given the name of the user interface control when it's interacted with. So for example, if I say Control P5.add button, whenever that button is interacted with, Control P5 will try and call a function in my code with the same name that I've given it. So if I say Control P5.add button my button, and then create a function called my button, so you can see here, if I say I have this function, my button, and in it I say my button was interacted with, because this has the same name as the name that I've given to the button up here, so inside quotation marks matches that one, whenever I interact with that button, you can't really see it, we'll just put an X at the end so we can see. So we can see every time I click on that button, it's calling my button was interacted with. So this is why we need to make sure everything has a unique name, because if I had two buttons, with the same name, let's move this one, my button 2.set position, 100, 300. So first of all, we can, well, actually, in fact, we can see Control P5 check name, control with the name my button already exists, and what it's actually done is it's overwritten the existing one. So when I've said my button, create a new one, which was the one up here, and then I've created a new button with the same name, what it's actually done is it said, well, you've given it the same name, so I'm just going to assume that's the same button. So when I've called set width, set height, set position, it's actually not a separate button now, but it's modifying the width and height and position of that original button, because we can't have more than one button or any control with the same name, because otherwise how would it know which of these functions to call? So what I could do instead is I could have my button 2, and now you'll see we have two buttons. My button was interacted with, and the other one doesn't do anything because I haven't set up a my button 2 function. But if I did void my button 2, then I can do the same thing here, my button 2, and now when I click on my button, we'll see my button was interacted with, and if I click on this one, we'll see my button 2 was interacted with. So we have to give every control in Control P5 a unique name so that it knows which function to call when we interact with it. So what about things like my color picker? Oops. So if we run this, my button 2, and my color picker. So my color picker doesn't actually seem to be doing anything when I interact with it, even though it has a function. And the reason for that is my color picker has a value. So if I interact with it, I'm probably changing the value of the colors. And so I have to have int value. And you can see now when I click on this, my color picker was interacted with. So it's telling us that it's been interacted with. We have some value which hopefully represents the change in value of my color picker. But if I try and print the value out, we can see it's kind of garbage, like negative 11,639,041. What does that tell us? It's not a red, green, blue alpha value. So what's actually happened with that value is that processing has a function called red, green, blue, and alpha, or functions called these, which will actually take an integer or an integer value and split them out into values for red, green, blue, and alpha. I think from memory, yeah. For some reason, these are floats rather than integers, which is sometimes a little bit confusing. But what we can actually do is we can get out the value that we actually want by using that int value and passing it into the red, the green, the blue, and the alpha functions, and that will extract from that integer value the meaningful values for red, green, blue, and alpha. So I can then say red, green, blue, and alpha. Oh, alpha's got an underscore. And so now if I change my color picker, you'll see that you can't really see on the screen, but these numbers on the color picker say 59, 255, 255, 255, and the values which have been printed out, 59, 255, 255, 255. Likewise, if I click on here, we've now got 59, 98, 255, 59, 98, 43, 59, 98, 43, 147. So this value which is passed in, this int value, is actually containing the values of red, green, blue, and alpha We just need to break them out before we can use them. So it's a little bit of a convoluted way of dealing with it. It's suboptimal, really, but unfortunately, this is the way we have to work with these things. Other controls say it's a checkbox. What do they call checkboxes in here? Or we can do it. Should we do a number box instead? So move up and down, change the value of number box. So let's say number box. Is that a capital? No. My number box equals cp5.add number box. So if we run this now, hopefully we'll get add number box string name. Oh, sorry, lowercase b. So if I do my number box dot set position 300 by 100. So we got this number box here, which is a box that I can, again, apologies, it's quite hard to see, but if I click on it and then drag up and down, the numbers will increase and decrease. If I have a function for that, again, because it is a control which has some sort of value. So a button doesn't have a value. If you click it, it has it's been clicked, but other than that, it doesn't really have a value. So we can call it without having any value. My number box, like the color picker, does have a value. So if I interact with it, I'll probably change some property of it. And my number box does as well. So my number box dot value, and you see, oops, it's not actually letting me do anything with it. Awesome. Okay, so this was a terrible example, and I apologize for that. Okay, it's literally not letting me do anything with that. Let's forget about that one for now. If we look at some of the other examples, I'm sure it will have how to do that. Add number box. Okay, so that one's number box. Okay, so there's a working number box there. I'm not sure what was, obviously there was something else I need to set up, so you can see, well, you probably can't, but as I'm moving left to right, that number's increasing and decreasing.
Must be a capital value B or no?
No, so that doesn't matter. I think one of these other things, like maybe the value or something, needed to be set before it will work properly. So now hopefully if I print the value, yeah, you can see. So as I decrease this, the number which is getting printed out is decreasing and increasing based on that. So a little bit confusing in that my color picker gives us a value and my number box gives us a value, where my number box will be the integer. So in this case, it's 115. If I decrease that to 92, it's a one-to-one mapping between the value which is displayed here and the value that we get in that function, whereas with my color picker, we have to do a little bit of processing on that value, so we have to break out the red, the green, the blue, and everything else before we can do anything with it, but unfortunately that's just kind of the nature of it. But let's go back, let's forget about the number box for the moment. Let's just look at the color picker and the buttons. So say I actually want to do something with this now, so we can detect when my button's clicked on, we can detect when my button 2's clicked on, and what values it's changed. So let's give this a little bit of interactivity. So let's move these values out. So I'm going to move the red, green, blue, and alpha values out of my color picker so that I can access them in a different function. We're still going to get the values for them from my color picker. And then in my button 2, we're going to say background red, green, blue. We're not going to worry so much about the alpha at this point in time. So what this allows us to do, assuming it works properly, is I can set a color, and you'll notice that when I change the color on the color picker, that very bottom bar down here will reflect the current color. So I can move that down and get a nice sort of orangey color. And my button 2, in this case, takes the value of red, green, and blue and sets that to the background color. So I can click on that. So now I have a user interface which allows me to customize the background color of my processing example. Simple little example, but sort of shows how you can pretty quickly and easily sort of throw together some user interface behavior to allow users to now start interacting with the processing example. Allows us to interact with the processing thing without actually having to write code. So I could export this and send it to you guys, and now you could start, changing the colors of the background or whatever. So I'll save that. So is everyone happy with what we've done? We've created a button, or created 2 buttons. We calling control p5.add button. We know we have to give them unique names, because those names will be the names of the functions that get called when we interact with them. We've taken the result of add button and stored that in some buttons that then we can call set width and set height on them, or set width and set height and set position, which allows us to position them. We've created a new color picker called my color picker. We've stored that value and set its position. Is that all fairly understandable, at least? Whether you guys would be able to basically write this from scratch right now, I don't know, but at least hopefully you could look at this and understand, okay, that's what's happening here. Setting up control P5, creating a button, creating another button, and creating a color picker. We have to have our draw method. Our draw method isn't doing anything. Control P5 is responsible for drawing all the controls, but it just has to be there. And then we have some events. So we have my button, we have my button 2, and they correspond to this button and that button. And then we have our my color picker, which corresponds to this control, and it has a value because a color picker has a value, which is the color that it's been set to. My color picker, we have to break out the red, green, and blue by using this red, green, blue, and alpha code with functions with value, and that allows us to get out these things. So if I gave you guys this, printed this out on a sheet of paper so you couldn't run it, are you guys feeling somewhat comfortable that you could at least sort of guess about what it's going to do? Yep. Okay, cool. That's all I'm hoping for at this point in time. I'm not expecting you guys to walk out of these lectures being like, yep, I can write this thing without ever having to see a reference manual or whatever. But if you could at least look at it and understand it, then you've got enough knowledge that you can download other people's code, or you can look at the examples or whatever and continue your learning from there. We don't have time for me to teach you guys from nothing to being experts, but if we can get you to the point where at least you can understand what you see when you see it, then hopefully you guys can continue your sort of learning and stuff in your own time. Okay, so let's throw some spanners in the works. You guys are comfortable with that, so let's make it a little bit harder. So what I wanted to do is I wanted to talk about this, this concept of how we can string manipulators together. It's a really powerful tool, but it's kind of confusing for newbies because it's not like anything we've seen before, but you will see it a lot in the examples they use in Control P5. And again, I want you guys to be able to look at the examples and understand what the examples are showing so that you don't get confused. Okay, actually let's start a new project so we can get rid of a lot of this extra garbage. Just gonna copy this first part here. Okay, so I've copied out just that first part of this Control P5 example we looked at. So we import it, we say that there's going to be a variable called Control P5, we set up the size, we create or set aside some memory, we actually create the Control P5 object with this, so it's able to call functions. But what I wanted to look at is this code here. So my button equals cp5.addButton, my button.setWidth, my button.setHeight. So we can use all these my button functions. What is it? I think it's called set label, change the buttons label. All these things to modify how my button looks. So now it says change the buttons label rather than my button. So my button.setWidth, my button.setHeight, my button.setLabel, my button.setPosition, all these things we can modify. However, there's something kind of special about the way Control P5 handles these set functions. And what that does is every time, so when we call Control P5.addButton, it returns a copy of my button, which I can store and then modify. However, that is also true of setWidth. So setWidth will return a copy of my button. So I could say button, my other button, or button 2 equals my button.setWidth, because setWidth will return a copy of that button after it's updated it. So I could say my button2.setHeight. Likewise, my button2.setHeight returns a copy of the button. And my button.setLabel returns a copy of the button. So all of these set functions return copies of the button. So you can see we end up with the same thing, even though I've said my button equals Control P5.addButton, my button 2 equals my button 3 equals my button 2, my button 4 equals my button 3. So each time we're getting a copy of that, well, not even a copy, we're getting the same button back. We say update the button and it says, okay, button's been updated, here's a reference to it back. And the reason for that is Control P5, because each of these passes a button back, what we could do, calling my button.setWidth will return a copy of the button. So what I can actually do is I can actually then call setHeight, and that will allow us to set the height of that copy of the button we've just gotten back. So just to illustrate that, if we have this example here, my button, Control P5 add button, so add button creates the button and returns it. My button.setWidth adjusts the width and returns it. My button setHeight adjusts the height and return it. But what we can actually do, this code here is actually the same as going, so if we take this here, setWidth will return a button, and we can then call setHeight on that button that's returned, and that allows us to string those two commands together. So now what we do is we call my button.setWidth, and that will return a button, and then we call setHeight on that button, and that whole thing will return a button. And so if we run this now, we will see that it's got the width and the height that we have set. So what you'll often see in processing is they will string all of these commands together. And remembering in processing white space, or actually we can take this one step further again. We could call my button equals add button, set width, set height. And so what we're doing is we're creating a button and that will return it. We're setting the width of that button and returning it. We're setting the height of that button and returning it. And we can string all these functions together to do our entire setup of that button in one go.
It's better to do it that way, or just?
It actually makes no difference. Yeah, it depends on what you find easier to read, I guess. But remembering that white space doesn't make a difference in processing and Java languages, what we can actually do is to make it a little bit easier to read, we can move that line down to there. So cp5.addButton.setWidth.setHeight.setLabel And we can keep going, adding a whole bunch of these after the other. And what it will do is it will call cp5.addButton, create that button. It'll call setWidth on that button, return a button. It'll call setHeight on that button, return a button. And it'll call setLabel on that button and return a button into my button. So you'll often see in Control P5 something that looks like this: Control P5.addButton.setWidth.setHeight.setLabel. And in fact, even that example that we pulled up before with the number box, we have here Control P5.addNumberBox.setPosition.setSize.setRange.setMultiplier.setDirection.setValue. So they're basically setting up all these things in one go. If we wanted to, there's no reason why we couldn't say number box. My number box equals that, and then just say my number box dot set position, my number box dot set size, my number box dot set range, my number box dot set multiplier, and so on and so forth. We actually end up with exactly the same result, because what it's calling the same functions on the same object. It's just this is a slightly shorter way of writing it. And as I said, programmers are inherently lazy, so this is how they've chosen to do it. Likewise, you'll see that they never actually, we capture the button. In this code, we say my button equals Control P5. You'll notice in a lot of their examples, they actually never bother storing it, because if you're going to set the values of it all at once, you actually don't ever need to keep a copy of it, because it'll all be there, and it's still going to call that my button function when you click on it. So do whatever you're most comfortable with. If this makes sense to you, calling cp5 add button, set width, set height, blah blah blah, do that. If you're more comfortable with the first way I did it, so this one here, no, not that one there. Where's it gone? I've lost it. This one here, my button equals Control P5 add button, my button.set width, my button.set height. If you're more comfortable with that, do that instead. As far as the actual program goes, it makes no difference. These will both run at exactly the same speed. They will both work in exactly the same way. If this makes more sense to you than chaining all of these commands together like this, then please, by all means, use that. There's no reason to not use it. The only reason I mention it is because all of the examples, you'll notice, are pretty much done like this. So if I didn't show you this, then it might be a little bit confusing as to what that actually means. So that's what I say by each manipulator. When I talk about a manipulator, it's just a word that I've made up. But effectively, I'm referring to functions where we set a value or we change some value of a control. So this function here, button1, add button, button1.setPosition, button1.setSize, is the same as button1, add button.setPosition.setSize. Okay, so there was one last thing that I wanted to touch on before we move on from Control P5, because this again is an example or something you may see in the examples. So I'm just going to copy and paste all of this code. Okay, I'll get rid of one of these buttons. Simplify things down a little bit. So I'm just going to, whoops. Just going to do their method of doing it because I want this to be hopefully nice and clean. And let's keep that one. Okay, so here we have a simpler example, importing Control P5, setting up the size. We have two controls, my button and my color picker. So if we run this, we've got my button. When I click on that, it says my button was interacted with, and the color picker, and when I click on that, you can see those values are changing as well. So like everything else in processing, there is more than one way to do anything. So I just wanted to show you this again, so hopefully if you see it in the examples it doesn't come across as being super, well, something you haven't seen before and super confusing. So in addition to having Control P5 call the MyButton function and the MyColorPicker function because of the names MyButton and MyColorPicker here, Control P5 also offers an additional function called control event. So you can see that in the top here. So control event gets called by Control P5 when any user interface item is interacted with. So a control event is a function that you can provide if you want it, you don't have to. And it takes one argument, which is a control event thing, or object or class, which is basically encapsulates whatever happens. So Control P5 will call this function control event to say, hey, something has happened, somebody has interacted with something, and here is a control event object that you can use to find out what that interaction was. So at the moment, I have just a print statement in there which calls c.getName. So if we run this again, you'll notice everything looks exactly the same. Let me see if I can make that a bit wider, make that a bit taller, and pop this over here. So now if I click on my button, we have a function called myButton which prints myButton was interacted with and prints out a number so we can see how often it's interacting with. So if we click on that, we'll see myButton was interacted with, but we've also got myButton printed out there. So myButton is being printed out by this control event function, and basically C, this control event object.getName, will return the name of the object which the event happened on. So when we click on our button, myButton, Control P5 calls the function myButton, but it also calls the control event function and it sets the value of c.name to be the name of that object. So clicking on that will now always print out myButton was interacted with because of the myButton function, but it will also print out myButton in this control event. Likewise, if I click on MyColorPicker, you'll see we've still got this MyColorPicker was interacted with function down here has been called, so MyColorPicker was interacted with red, green, blue. But we also have control event print, the println getName has printed out MyColorPicker. So what we could do is we could have a pretty simple if statement, if c.getName equals myButton, println control event was called because of myButton, else if c.getName equals MyColorPicker, println control event was called because of MyColorPicker. Let's get rid of that. So now if I click on my button, it will say myButton was interacted with 0, which is from the myButton function, but also control event was called because of myButton. Or if I interact with the color picker, control event was called because of MyColorPicker, and MyColorPicker was interacted with. So they're exactly the same ways. If you remember back to when we were talking about interaction, we had things like void key pressed was a method you could use to detect if a key had been pressed, or in the draw method you could have something like if key pressed equals true. Both of these things did the same thing. One, the function would be called when the key pressed, or in the draw method we could check to be key pressed. This is control P5's same thing. We have either a function which gets called when a control is interacted with, or the control event is like our draw function where we can say which control has been interacted with. So likewise, if we have something like our color picker, we can get the values of it. C has, in addition to a getName function, it has a getArray value function which will return some array values. So in the case of a color picker, it gets 4. Red is the first one. green is the second, blue is the third, and alpha is the fourth. So printing get array value 0 will give us the red value of the color picker, green will be get array value 1, blue will be get array value 2, and alpha will be get array value 3. So if I run this, click on the button, my button was interacted with, control event was called because of my button, or if I change a value on the color picker, we have control event was called by my color picker, red equals 90, green equals 255, blue equals 255, alpha equals 255, and that's exactly what we've got down here, 90, 255, 255, 255. Probably should put spaces in between those so we could see them a bit easier. There we go, 255, 255, 75, 75, 255, 255, 255, 255. So again, two different ways of doing the same thing. Whatever you feel more comfortable using is the right answer. If you want to ask which is the best way of dealing with user interaction, it is whatever way you are most comfortable with. If you're most comfortable with having a separate function for every control, do that. If you're more comfortable with just having one function which goes through and, you know, if it's this, do that, if it's this, do that, if it's this, do that, that works absolutely fine. It will have basically no impact, no effect on how your code performs or anything like that. It all just comes down to personal style and preference. Okay, that is a very brief look at Control P5. I know we haven't really gone into any great depth with it, but we also just don't have the time to do so. But what I would recommend, P5 events. Again, I'll upload all of this to Learn. I would highly recommend, now that we've sort of looked at how Control P5 works, what the various bits of it are, going through these examples and having a look at each of them. The examples for Control P5 actually aren't too bad, like they're not crazy complicated. So something, you know, like this, which looks quite complicated, is actually only, you know, a handful of lines of code in here. So they've added a color wheel C. Yeah, there's not a huge amount of code in there that you can hopefully, now that we've looked at the various ways of how Control P5 works, we can look at those and sort of pull them apart and understand, oh, okay, in order to use a color wheel, this is how I do it, or in order to use a, what else we got, a drop-down list, you know, this is all the lines of code, so it has just a handful of lines of code to do so, and when we run that, we have our drop-down lists that we can use if we so choose. We haven't spent a huge amount of time on Control P5 or GUI stuff in processing because it's probably something you're more likely to use when we get to Unity, and in Unity it's very much drag and drop sort of stuff. The assignment this year will be in Unity, so you don't have to worry if stuff isn't clear, but some of the overlap between how Control P5 works and how Unity works is kind of similar. Unity just provides a lot of drag and drop stuff rather than having to write the code for it. So it's still good to learn this stuff because you may have to do some of the stuff when it comes to like interacting with them. So in Unity, for example, you still have to write something like your you know, my number box function, except you're allowed to, you can drag and say this is the function that I want to use, rather than Control P5 forcing you to use a specific function. Yeah, so is that all, you know, probably something that you guys need to play with, but hopefully at least now you're comfortable that you can look at some examples and understand, follow along how they work. Does anyone have any questions?
Is any reason because you have used float numbers for the RGB numbers? Or?
So that was just what Control P5 works with. So it works with floating point numbers for all the values. Why that is?
You can use integers.
You can convert them to integers and it'll be fine. Control P5 will always give you a float though, because that's how it passes in the values are. Well, actually, so it passes an int value. If we call like my color picker the function and you get int value, the red, green, blue alpha functions take an integer and return a float. But you could convert it to an integer and it would work fine. Yeah, so it's just the way that those functions work. You'll notice that they're always like 255.0, 129.0. So you can treat them as integers without any real harm. It's just, yeah, how they've chosen to make it work. Any other questions? No? Okay, let's wrap it up there, I think. It's a lot to take in. We will move into, hopefully get through the rest of these slides on Thursday, and that will kind of wrap up processing, and then we're going to move into 3D graphics, which will segue us into Unity. So we are, you know, I'm always a bit, like every time I teach this course, I'm always like, is it really worth it sort of teaching the processing stuff? Because a lot of you guys will probably very quickly move on past processing and into Unity, because it allows you to do, there's a lot of stuff that processing forces you to do in code, whereas in Unity you don't have to. You know, like displaying a 3D model in processing is quite an arduous task. In Unity you literally just drag it into the window and it's there. But for things like programming, I think processing is a much gentler way into it, whereas Unity, you sort of go in there and it's like, hey, there's all this stuff, everything is already object oriented, everything has inheritance, everything, you know, works in this way, that if you're not a programmer, it's like me trying to explain to you how object oriented programming works when we haven't actually talked about how programming works. So it's sort of this thing that, while it may feel like, you know, it's kind of useless learning the processing stuff, the point is that hopefully we're sort of gently introducing you to it, so that by the time we get to Unity, you'll be like, oh, this is so much easier than doing it in processing. But it's only easier because you've already learned the hard stuff first. And that's exactly in this other course I'm teaching, which is really more advanced sort of stuff. Again, I started with processing because none of them had done any programming, and as much as I wanted to just say, well, processing isn't important to you guys, let's just focus on Unity, I feel having that more gentle introduction into programming through processing has made it easier for them, rather than just sort of saying like, okay, here's Unity in C# using object-oriented programming. You guys don't know what programming is, let alone what object-oriented programming is, let alone what inheritance is, but you're just going to have to accept that it all works. So hopefully this more gentle introduction will make it a lot easier by the time we get to Unity. And a lot of the skills are fairly transferable as well. There are some stuff, like particularly when we get to this processing themes part, this is more stuff which is specific to processing, but will allow you to still do stuff in processing, and is still, you know, everything we covered before we started processing themes is like 99% transferable. Everything in the processing themes is maybe 70% transferable. So it's not as useful, but we'll still hopefully give you guys some grounding in everything. And particularly the next topic we're going to look at is audio. Again, the code we write is different, but all the theory is the same between processing in Unity and any other language or platform that you might want to use. Cool. Otherwise, let's wrap it up there. And